we will be discussing about Physics Paper 1, MCQ Paper 2020, May-June, variant is 11 and the subject code is 9702. Number 1. What is the reasonable estimate of the kinetic energy of the car with speed 30 meter per second? So we know the speed and kinetic energy is equal to half mv square. So what would be the mass? So for the car, we consider the mass as 200 kg to 1000 kg, and after placing the value we get our answer as 0.9 into 10 to the power 6, that is approximately equal to 1 into 10 to the power 6. So the answer would be C, and this is the mass of the car, and if it is an adult then the mass would be around 60 to 70 kg. The frequency of vibration of mass m supported by the spring with spring constant k is given by the equation. So this is basically the equation we have given, and it says that C has no units, so we have to remember that C has no unit. We need to find the value of P and Q. So as C has no unit, that means if we make C becomes a subject formula, then the overall unit becomes 0. That is, overall unit becomes 0. So what is F? F is the frequency, and frequency is equal to 1 by time period, that is 1 by second, so the unit would be per second. Then the SI unit of mass is kg. The K would be that spring constant is equal to force per unit extension, and the SI unit of force is kg meter per second square. And for extension, as extension is a length, so it is measured in meter. So after inputting these quantities, we can see that as C has no unit, that means the unit becomes 0. That means this kg would cancel with this kg. So P and Q have a value that cancels each other out. That means it can be negative 1 by 2, negative 1 by 2, 1 by 2, that is the overall unit becomes 0, and 1 by 2, negative 1 by 2, that is overall unit becomes 0. But it can be a unit of 1 or it can be a unit of negative 1 because the overall unit is 0. So it can be either B or C. Then per second, so per second divided by second squared, so we need to make this per second, and to make this per second we need to multiply it by 1 by 2 so that it becomes per second. Thus this would cancel with this unit and the overall unit becomes 0. So we can see that this is per second, so Q is per second, that is Q is 1 by 2, that is Q is 1 by 2, and P is negative 1 by 2. The power produced by a force moving an object is given by the equation shown. That is, power is equal to work done by time taken. Work done is equal to force into displacement by time taken. Which of these quantities are scalar and which are vector? So scalar quantities include power and work. Since power has no duration and work has no duration, so these are scalar quantities, while displacement and force is a vector. Displacement is obviously a vector and force is a vector, since that 10 Newton force due to gravitational force acting downwards or 5 Newton force acting upwards. So whenever we mention force, we also mention direction, so it would be a vector. So the answer would be B. Number 4. A cathode ray oscilloscope displaces a square wave as shown. The time-based setting is 20 millisecond. M is represented by milli, that is 20 or 0.2 into 10 to the power negative 3 second. So time-based setting, that means each small square box is this much value. Then we need to find the frequency. We know that frequency is equal to 1 by time period. So what is the time period? Time period is the time taken to complete one complete wave. So what is one complete wave? If we draw this like a wave, then this should look something like this. So as you can see that this is basically a wavelength, that is, this distance to this distance is a wavelength. So we need to find the time taken to complete this much wavelength. So this much wavelength completes about 9 boxes. So overall time period is time base into 9, and we know the time period, so frequency is equal to 1 by time period, that is 555.55 Hz. So this value is not equal to but closest to 830, so the answer would be B. Number 5. Measurements are taken correctly but with a ruler at significantly higher temperature than that at which it was calibrated. The higher temperature causes the ruler to expand. So due to this higher temperature, the ruler expands. What does the effect of the measurement caused by the higher temperature? So what is the effect of the measurement and how the measurement can be improved? Effect is basically that the measurement will be subjected to a random error, No, it would not be a random error. It is basically a systemic error that occurs all the time, whatever the reading we take. So it is not a random error. Random error is caused by the person, but the systemic error is due to the system. And as we can see that the system is, as there is an error in the system, that is the ruler, so it would be a systematic error. And the error would be consistent, that means remains the same. Thus it is not a random error, it is a systematic error. Then the measurement can be made more accurate by taking average of several readings. So the measurement cannot be made accurate because the readings we take are very much different from the original reading. But we can make the readings precise by taking the average, because precision means that the range of our measured value. So if we take the average, then our measured values would be close together. So we can actually make the readings precise, not accurate. That means our range of values would be close together or very much similar to one another. So if we consider this diagram, then as we can see that our measured values are within this range, so this is precise. But as we can see that it is not close to the original value, so it is inaccurate. So by using the ruler, we get this type of graph that it is precise but it is not accurate. So the answer would be D. Number 6. The velocity of electric car changes as shown. What is the acceleration of the car? So to find the acceleration, we know that acceleration is equal to velocity by time. So what is the velocity? So suppose at this point, this is basically 150 minus 100, that is 150 minus 100 by, this is 10 boxes. So after dividing by 10, each small square box becomes 5. So this is basically 105, that is the velocity is 105. And when the velocity is 105, time is 4. But we have to careful about the units, that is velocity is kilometer per hour. So we need to convert it to meter per second. Then we know the velocity and the time. So acceleration is equal to velocity by time. So it comes to be 7.29, that is equal to 7.3. So the answer would be D. 7. A projectile is fired from P, that is at this point, with velocity v at an angle theta. It lands at point Q, a horizontal distance r from P. So this is the distance r. After time t, the acceleration of free fall is c. The air resistance is negligible, so air resistance is negligible. Which equation is correct? So if we consider these equations, first of all, as it is thrown at an angle, so the horizontal component of velocity is v cos theta and the vertical would be v sin theta. So here we can say that r is common on both the in all the options. So r is equal to, that is r is the distance. So we know that distance is equal to velocity into time. So as it is a horizontal distance, so we have to take the horizontal velocity, that is v cos theta, into time. So the answer would be v cos theta into time, that is A. 8. A car accelerates from rest, that means at velocity is equal to 0, that is u0, in a straight line with a constant acceleration. So whenever we take the acceleration constant, so we can use the equation such as v square minus u square is equal to as, v is equal to u plus at, s is equal to ut plus half at square. So we can use this equation when acceleration is constant. So as acceleration is constant, so we can use this equation. So which graph best represents the variation of momentum of the car with distance s traveled by the car? So all these graphs are momentum against time graph. If we consider the equations that we usually know, then force is equal to mass into acceleration, or force is equal to change in momentum by change in time. So and momentum is also mass into velocity. So we can use this equation to relate with distance, since velocity is equal to that v square minus u square is equal to 2as and initial speed is 0. So v would become root over 2as. That is, we can use this equation to relate momentum against distance. So we can see that momentum is equal to mass root over 2as, that is change in momentum is directly proportional to root over distance. That is, momentum square is directly proportional to distance. We can write this as this form. Just we multiply both sides by square, so this would cancel, and momentum square is directly proportional to distance, or s. And for directly proportional graph, if it is just proportional, directly proportional, then it would be a straight line. But since it is momentum square, so the graph would tilt towards the momentum axis. And if it is, thus it is momentum square, so it would just tilt towards the momentum axis since it is square. But if we suppose that it is momentum against distance square, if it is distance square, then instead of being a straight line, it would slightly tilt towards the distance axis. That is, since it is a square, so whatever the square is, it would tilt towards that side. That is, if it is square s square, they need to tilt towards the square side, that is the S side, and if it is momentum square, then it would tilt towards the momentum side, that is this side. And this is the graph A that we get our answer since it is momentum square, so it will tilt towards the momentum axis. The resultant force F on a raindrop of mass m falling with a velocity v is given by the equation. So this is the equation we have given, where k is the constant, g is the acceleration of free fall. What is the velocity of the raindrop when it reaches a constant terminal velocity? So at constant terminal velocity, we know that since acceleration is 0, so resultant force is equal to mass into acceleration. So resultant force is also 0 since acceleration is 0. So at terminal velocity, resultant force is 0. So after considering it to be 0, we solve this and get v is equal to root over mg by k, that is the answer C. 10. A stationary toy gun fires a bullet. Which statement about the bullet and the gun immediately after firing is not correct? So we have to pick a statement that is wrong. So force exerted on the bullet by the gun has the same magnitude as the force exerted on the gun by the bullet. So this is Newton's third law. So this statement is correct as both the objects exert equal forces on each other. Then the force exerted on the bullet by the gun is in opposite direction. So on the bullet by the gun is in opposite direction to the force exerted on the gun by the bullet. So yes, these are in opposite direction. Since the force by Newton's third law, forces are equal in magnitude but acts in opposite direction. So this statement is also correct, but we have to pick the wrong statement. So the gun and the bullet have the same magnitude of momentum. So we know that since the objects are exerting the same force and the time taken is the same, or the time interval is the same, so we know that the change in moment force is equal to change in momentum by change in time. So since force is same, change in time is same, so change in momentum is also same for both the objects. So statement C is also correct. Then the kinetic energy of the gun must be equal to the kinetic energy of the bullet. This statement is actually wrong because in addition to the kinetic energy, some of the heat energy is also produced between the firing. Thus, kinetic energy is not the same, but total energy is conserved or total energy is same. So kinetic energy may be different due to heat energy produced. So the answer would be D. A wooden block rests, that means at velocity is equal to 0 on a rough surface, that means frictional force is acting. One end of the board is raised until the block slides down the board with a constant velocity. So as the ball slides down the board, that means the block is moving down the board. So as it is moving downwards, so frictional force will act upwards. So what describes the force acting on the block when it is sliding with constant velocity? Since it is sliding with a constant velocity, that means driving force is equal to resistive force. That means, okay, frictional force on the block. So in which direction frictional force is acting? Since the block is moving downwards, so frictional force is always upwards. Then the resultant force on the block. So since we know that it is moving at a constant velocity, that means driving force is equal to resistive force. That means the resultant force is 0. Since at a constant velocity, we know that the resultant force is equal to mass into acceleration. Since at a constant velocity acceleration is 0, so resultant force is 0. So the answer would be D. 12. Which statement best describes a couple? So a couple is basically two forces that are in equal magnitude acting in opposite direction that causes the object to rotate. So for the formula of couple is the force and the perpendicular distance between the two forces. That is the force and the perpendicular distance between the two forces. So this is the formula for couple. So which statement best describes a couple? A pair of forces of equal magnitude. Yes, the forces are of equal magnitude acting in opposite direction. Yes, which causes the object to rotate. This statement is also correct, but no translational motion. That means it only causes the object to rotate and nothing else. So the option A would be correct. 13. A uniform rod XY of weight 10 Newton, that is the uniform rod. Since it is a uniform rod, so the weight would act at exactly the center, is freely hinged at the wall at X. So at point X it is hinged, it is held horizontal by force F acting from Y. So the force F is acting from point Y at an angle of 30 degrees to the horizontal. So what is the value of force F? So we can see that for this system, since the system is in equilibrium or in rest position, so the clockwise moment is equal to the anti-clockwise moment. So clockwise moment is in this direction and anti-clockwise moment is in this direction. So clockwise force is 10 and we take the total length as 2x. So half the length would be x and this length is also x. So 10 into x, that is from the center. So 10 into x is the clockwise moment and anti-clockwise moment would be, since we are considering the vertical forces, so for F the vertical force would be F cos 60. So F cos is 60 and the total distance would be 2x. So after equating this, we get the force as 10 Newton, that is the option C is correct. 15. Four combinations of vectors are shown, each representing all the forces acting on an object. The forces all act in the same plane. The object is in equilibrium. Since the object is in equilibrium, that means the resultant force is 0. That means if we consider three forces, then it would be in such a direction that the arrow's head are pointing in opposite direction. That is, if this arrow is in this side, then this would be in this side, then this would be in this side. That means it forms a closed triangle. So which combination of vectors would represent the forces acting on an object that is in equilibrium? So as we can see that for the first option, since it would not form a closed triangle, so option 1 is wrong. That is, this arrowhead meets with this arrowhead, so this option is wrong. Then in option B, we can see that if we place this force exactly in this side, then it would not form a closed triangle since its length is bigger. So option B is also wrong. In option C, we can see that if we place this arrow such that it points in this direction, that is by head to tail, we can see that it is not forming a closed triangle. So this option is also wrong. But if we place this arrow in this direction, in this place, so we can see that this arrow is pointing in this direction, this arrow is pointing in this direction, and this arrow is pointing in this direction. So this forms a closed triangle and the forces are equal in magnitude. So the overall moment is 0. So the option D is correct, that is the object in equilibrium. 15. A rectangular metal bar exerts a pressure of this much on the horizontal surface on which it rests. The height of the metal bar is 80 cm. What is the density? We know that the pressure is equal to rho gh. So we know the value of pressure. We know that g is the gravitational field strength, that is 9.81, and the height is 80 cm. So we need to convert it to meter, that is by dividing with 100. And we need to find the rho. After equating this, we find the rho as 1936.7. It is approximately equal to 1900. So the option B is correct. 16. A mass is attached to the lower end of a spring that bounces up and down. So this spring bounces up and down, and here is the mass. At which point in the path of the mass do gravitational potential energy of the mass, the elastic potential energy of the spring, and the kinetic energy of the mass have the highest value? So we know the gravitational potential energy is equal to mass into gravitational field strength into height. That is, gravitational field strength increases with height. That means at the topmost point, it has the highest gravitational potential energy. Then elastic potential energy, if we consider elastic potential energy, then since the object is stretching, so as long it is stretched from its initial position, it has more elastic potential energy. So at the bottom point, it has the most elastic potential energy since its length is greater, that is, its extension is greater. Due to the larger extension, the elastic potential energy is lower at the elastic potential energy is higher at the bottom. Then at which point the kinetic energy is highest? We know that at the bottom point the speed is 0, and at the topmost point the speed is 0. That means at the middle kinetic energy would be the highest value. Also, why we say that at bottom or the top point kinetic speed is 0? Because as we can see that for maximum or minimum displacement, the speed is 0. Or at this point it comes to rest for a few seconds, then again it moves upward, and at this point it rests for a few seconds. But at the middle point it has the highest speed, so the kinetic energy is highest at the middle, so the option C is correct. A block of weight 80 Newton is pushed a distance of 60 cm up the slope. So the block is pushed up the slope at an angle of 30 degrees to the horizontal. There is a frictional force of 25 Newton between the block and the surface of the slope. Since the object is moving upward, so the frictional force would act downwards. So what is the work G done against gravitational force and the work F done against frictional force? So work done against gravitational force, that means the work done due to the weight. So weight, that is 80 Newton, is acting vertically downwards, and from the surface we need to in respective to the surface we need to find the horizontal and the vertical component of weight. That is, the vertical component is 80 cos 30 and the horizontal component is 80 sin 30 in respective to the plane. So we know the horizontal component, and work done due to the weight or the gravitational field strength is work done is equal to force into distance, and it must be the gravitational force. So the gravitational force in respective to the plane is 80 sin 30, and the distance moved in the direction of the force, that is, the distance moved in the direction of the force is 60 cm, and we must convert the centimeter to in meter. So work done against gravitational force is 24 joules, and the work done against friction. So what would be the work done against friction? We have given the frictional force, and we know that the work done is equal to force into distance moved in the direction of the force. So the distance is 60 centimeter. So we have to divide this value by 100, and we get the frictional force as 15. So the answer would be B. A ball is dropped from rest. At rest, speed is 0. That means initially it is at rest and falls towards the ground. So the ball is at a height and it falls towards the ground. Air resistance is negligible. Which graph shows the variation with speed of the height of the ball above the ground? So this is the height against speed graph. That means initially it has the highest gravitational potential energy and it is at the highest height. So initially the height has the highest value and speed is 0 since it is at rest. So initially height has the highest value, that is option A and C, and speed is 0. So option A and C would be correct, but here we can see that height is 0, so the option B and D are wrong. Then after it is released, at this point it has a height of 0 and it has some speed, so both the graphs show the speed. Then to differentiate this, we know that initial gravitational potential energy is equal to final kinetic energy. Since the energy conversion is the initial gravitational potential energy is equal to final kinetic energy, since no other energy is converted as work done by air resistance is negligible, so initial gravitational potential energy is equal to final kinetic energy, that is mass into gravitational field strength into height is equal to half mv square. So mass will cancel each other out. Then gravitational field strength is constant, so we can ignore this, and half is also constant. So by using the relationship we can see that height is directly proportional to v square. Since height is directly proportional to v square, so instead of being a straight line, it would be a curved graph since it is v square. If it is just height is directly proportional to v, then it would be a straight line, but as it is v square, so it would be a curve. So the option C is correct. The power is transferred through a machine as shown. So this is the input power, output power, and power loss. What is efficiency of the machine? We know that efficiency is equal to useful power output by total power input. So useful power by input power, so the option is B. Number 20. A tensile force is used to extend a sample of material. The force is then removed. The variation with strain of the applied stress is shown on the graph. Which point on the graph could represent the elastic limit of the material? Before the elastic limit point, the limit of proportionality comes, or the point of limit of proportionality comes such that the graph starts to become non-linear, or after limit of proportionality, the graph starts to become non-linear. So at this point, this is the limit of proportionality, after which the graph starts to become non-linear, and the elastic limit would be after the limit of proportionality. That means the closest answer is B, so the answer would be B. A tensile force is applied to an unstretched rubber band, causing it to stretch. The tensile force is then removed. Which statement about the rubber band must be correct? So it mentions about must be correct. If the rubber band stretches elastically and then plastically, all the work done by the force is converted to thermal energy. So if we draw the stretch strain graph, so the graph would look something like this, that this much of the work done is converted to thermal energy, but not all the work done is converted to thermal energy, so the option of A is wrong. If the rubber band stretches elastically, then it obeys Hooke's law. This statement is correct, but this is not must be correct. So if we see option C, then if the rubber band stretches elastically, the gradient of force extension graph is the work done. So the gradient of the force extension graph is not the work done. This is the gradient of force extension graph, and this is not the work done. This is actually the spring constant K. That is, spring constant K is equal to force by extension. That is, this gradient is spring constant K. But the graph of stress strain is the work done. So work done is the graph of stress strain, not the force extension. Then if the rubber band stretches plastically, the rubber band will be longer after the force is removed than it was before the force is applied. So this statement is obviously correct, because if the rubber band stretches plastically, then the rubber band would obviously become longer after the force is removed than it is before. So due to this plastic deformation, the length of the rubber band increases, and so the option D is obviously correct. So the more appropriate answer is D. In question number 22, a sound wave reduces its intensity but maintains a constant frequency as it travels through air. Which statement is correct? The maximum displacement of the particle changes between one particle and the next particle. So as we can see that intensity is reduced, so intensity is directly proportional to amplitude square. Thus, if intensity changes, then maximum displacement also changes. That means the amplitude also changes. So this statement is correct. Then the phase difference between adjacent particles is 0. This statement is actually wrong because between adjacent particles there is always some phase difference. But if we consider a stationary wave, then for a stationary wave between two adjacent nodes, that is this node and this node, the phase difference is always the same. That is, between adjacent nodes, points vibrate within the phase and have a phase difference of 0 degree. But outside that node, that means if we consider, then suppose at this point and at this point, then these 2 points have a phase difference of 180 degree. That means these are out of phase. But between 2 nodes, these 2 particles are within phase. That means they have a phase difference of 0 degree, and these 2 points have a phase difference of 180 degree. This is only for stationary wave, but since we are discussing about sound, so this statement is wrong, that the phase difference between adjacent particles is 0. This is wrong. Then the wavelength is the distance between 2 particles that have a phase difference of 180 degree. So wavelength is the distance between the 2 particles that have a phase difference of actually 360 degree, not 180 degree. This would be 360 degree, since if we consider this point and this point, these 2 particles are within a phase difference of 360 degree. So this is one wavelength, and the phase difference of 180 degree means that these 2 points, that means the phase difference of 180 degree causes lambda by 2, not lambda. Then the 2 particles have a phase difference of 360 degree, have the same maximum displacement. If the 2 particles, suppose this particle and this particle have a phase difference of 360 degree, so these 2 particles have the same maximum displacement. Yes, this statement is correct, but according to the statement that we have given, the more appropriate answer is A. So the answer would be A. The graph shows the variation with time of displacement of an electromagnetic wave at a point. The displacement and time graph. So the wave is traveling in a vacuum. What is the amplitude and the wavelength of the wave? So for the amplitude, since it represents displacement, so from a stretch position it is the maximum displacement, so the amplitude is 3, that is 3. Then what is the wavelength? So we have given the time. So what is the time period? That means the time taken to complete one complete wave. So this is one wavelength, so the time period comes to be 20, or it is microsecond, so 20 microseconds. So time period is 20 microsecond, that is 20 into 10 to the power negative 6 second. So we know the time period, so frequency is equal to 1 by time period. So we found the frequency, and since it is a electromagnetic wave, so we can use the equation v is equal to f lambda, as its speed is 3 into 10 to the power 8. We know the frequency, so the lambda comes to be 6000. So the answer would be A. 24. A long glass tube is almost completely immersed in a large tank of water. A tuning fork is stuck and is held just above the open end of the tube as it is slowly raised. A louder sound is first heard when height edge of the end of the tube above the water is 18.8 cm. A louder sound is next heard when h is 56.4 cm and the speed of the sound is given. So first louder sound is heard, that is at a distance of this much length, and the second louder sound is heard at a distance of this much length. And since it is at the closed end and at the open end, so at the open end always antinode is formed, and at the closed end node is formed. So the first case would be like this, and the second case would be this. For the first case, it is lambda by 4. So lambda by 4 is equal to 18.8. So lambda comes to be 75.2 by 100, since it is in centimeter. So we get this much lambda, and by using the second case, that is this much length is lambda by 4, and this is lambda by 2, since it is half a wave length. So the total comes to be 3 lambda by 4, that is equal to 56.4. So we would give the same answer. So we know the value of lambda. What is the frequency of the sound produced by the tuning fork? So what is the value of frequency? We know the value of lambda. We know the speed of the sound. So v is equal to f lambda. After equating this equation, we get the frequency as 438.8 Hz. So the closest answer is B. And it is a closed end and an open end. But if both the ends are open, then the first case would be like this, and the second case would be like this, that since both the ends are open, so at both the ends antinodes are formed. So this length is basically lambda by 2. Since if we consider this, then this is one wavelength and this length is lambda by 2. that is this length. Since if we complete this, then this is the one wavelength and this is lambda by 2, and this is approximately lambda. This is lambda. So this is for the open end and this is for the closed end. If both the ends are open, then we would get this type of lambda, and if both the ends are closed, then we would get this type of lambda. And for this type of situation, that is one end is closed and the other is open, the lambda varies in such a way that lambda by 4, 3 lambda by 4, 5 lambda by 4, then 7 lambda by 4. This would increase in such a way. And for this type of situation that both the ends are open, then it would be lambda by 2, 2 lambda by 2, that is lambda, then 3 lambda by 2, then 4 lambda by 2, 5 lambda by 2. This would increase in such a way. So this would be the case for these two differences or these two scenarios. 25. A source emitting sound of single frequency fs travels at a constant speed directly towards an observer. So first of all, it moves towards the observer, then the source passes the observer and continues to move away from the observer. So it moves directly away from the observer. The velocity of the source remains thus constant, which graph represents the variation with time of the frequency FO of the sound heard by the observer. So we know that FO is equal to FSV, V plus minus Vs, and for the object moving towards the observer, it would be minus Vs, and for the object that is moving towards the away from the observer, it would be plus Vs. So towards, that means minus, and away means plus. Then for the first case, this is the source frequency, that is Fs. So what would be the graph that is correct? First of all, the object moves towards the observer, and since it moves towards the observer, so there would be a minus, thus the denominator value is less, thus the FO value is more. So FO value is more than the source frequency. So it is more, that is this value is more and this value is more, but this is less and this is less, so option A and C are wrong. Then for B and D, which one is correct? So by using these equations, we can see that the velocity of the source is constant. So the velocity of the source is constant, so this value is constant. And the speed of the sound is obviously constant, that is V is constant. So these two things are constant. Then frequency of the source is also same, because for this type of cases, we take that frequency is the same, that is the frequency of the source is same. Also it is mentioned that a single frequency, that means frequency of the source is same, that is constant. So as all the things are constant, therefore FO would be a constant, thus it would be a constant straight line, and nothing is increasing or decreasing, it would just remain constant. Then after that it would remain constant, there is no increase or decrease, just a constant. Since all these things are constant and nothing is really increasing or decreasing, Fs is a single frequency, so it is constant. Speed of the sound is obviously constant, then speed of the source is constant, so FO would also be a constant. That means nothing is increasing or decreasing, it would be just a constant. Then as it moves away from the observer, so it would be plus Vs, that means denominator is more, therefore FO is less, so it would be less than Fs, so it would be in this place. So the option B is correct, and in option D it is increasing and decreasing, so this is wrong. What are the names of electromagnetic waves that have wavelength in a vacuum of 100 picometer and 100 micrometer? So pico means 10 to the power minus 12 and micro means 10 to the power minus 6, that is 10 to the power minus 6. So 100 picometer means 1 into 10 to the power minus 10 and 100 micrometer means 1 into 10 to the power negative 4. So for this type of cases, you need to remember the wavelength, and so this is the wavelength of radio wave, that is 10 to the power 4 to 10 to the power negative 1, microwaves, that is 10 to the power negative 1 to negative 3, then radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-ray, gamma ray. So these are their wavelength ranges. Then wavelength, so wavelength of 100 picometer, that means this value, that is 10 to the power 10. So 10 to the power 10 is between 10 to the power 9 and 10 to the power 12. So the answer should be X-ray, that is this value, not gamma ray, since it is above, but within this range 10 to the power 10 first comes. As we can see that it starts from 10 to the power 10, but 10 to the power 10 is a middle value, so it is more accurate. So the answer would be C or D. Then wavelength of 1 into 10 to the power negative 4, that is negative 4 implies that between negative 2 to negative 6 there is negative 4, so the answer would be infrared. So the infrared, that is option C, is correct. 27. The diagram shows a string stretched between fixed points x and y, there is a stationary wave on the string. The solid curve shows that the string is at a position of maximum displacement. The dashed line shows that the other position of maximum displacement, and the straight central dashed line shows that the mean position of string, that is the mean position is 0. Point S is on the string that is directly above point P. So this is point S and this is point P. Point T on the string is directly below Q. Which statement is correct? A short time later, point R on the string will be displaced. Now as we can see that this is a stationary wave, that means nodes would not move and it would remain on its position, but this parts, that is antinode, moves but node does not move. So R remains on its own position, so it is not displaced. Then point S and T on the string move in opposite direction. So as we can see that point S and point T are out of phase, that is they are not within two nodes. So yes, they are out of phase and so they vibrate in opposite direction and they have a phase difference of 180 degree. That is, since they are not separated between they are not between two nodes, so they have a phase difference of 180 degree. But if it is between two nodes, that is point S and point T are within two nodes, then they have a phase difference of 0 degree. But since they are out of phase, that is out of two nodes, so they have a phase difference of 180 degree. So yes, point S and T are moving in opposite direction since they have a phase difference of 180 degree. The distance between P and Q is one wavelength. So this is point P and this is point Q. So if we consider this, suppose, then the point P is in this line and point Q is in this line. So this distance is basically lambda by 2, not one wavelength. So option C is also wrong. Then the 2 points on the string that are equal distance from R vibrate in phase. So this statement is wrong, because if we take this point and this point, that is the equal distance from R, then they are separated not between two nodes, that is this node or this node or this node or this node. So they vibrate out of phase and they would vibrate out of phase, not in phase. So the option D is wrong and the answer is B. 8. Which statement must be true for diffraction to occur when wave passes through a gap? So when wave passes through a gap, the wave is able to travel in vacuum. This statement is wrong because this is for electromagnetic waves, or this statement is for electromagnetic waves that it travel in vacuum. But the wave is progressive. Yes, this statement is correct, because for progressive wave it can travel but as it passes. But for a stationary wave, we can see that stationary wave remains stationary and it would not pass. So the wave must be progressive. So this statement is correct, that the wave must be progressive, not stationary, because stationary wave would not pass and it would remain on its own position, as stationary wave is stationary. So for the wave to pass, it must be progressive. Then the wave has a larger amplitude. Again, this statement is not must be correct, because there is no such statement that is given. Then the wave has a long wavelength. Again, this statement is wrong, because for a diffraction to occur better, the width of the gap is approximately equal to the wavelength. If this occurs, then the diffraction is better. But there is no such statement that wavelength is long or this. So the option B is correct, that the wave must be progressive. 29. A light of single wavelength is incident normally on two slits that are 0.20 mm apart. That is, the distance between the two slits is 0.20, that is this much distance. Then the interference fringes are observed on the screen, that is 5.4 meter away from the slit. So this is distance T. Then the distance between the successive bright fringes is 12 mm. That is, the distance between the successive bright fringes is 12 mm. That is x. So what is the wavelength of light? So we know that the value of x, the value of a, and the value of d. So we know the equation that lambda is equal to ax by d. So after substituting the value, we get the lambda as 444 into the power -9. So the answer would be 440 nanometer, that is 440 into 10 to the power -9. So the answer is correct. A diffraction grating and the screen is used to determine the single wavelength lambda of light from a source. What is the essential feature for this experiment? So for a diffraction grating, we know the equation that d sine theta is equal to n lambda. So a curved screen must be used. So this statement is wrong, because for a diffraction to occur, we don't need a curved screen, because as we can see that this is a straight screen and by using this we can form a diffraction. So the option 1 is wrong, or option A is wrong. The diffraction angle must be measured for at least 2 interference maxima. This statement is also wrong because we can measure angle for 1 interference maxima and it will be okay. The light waves incident on the diffraction grating are coherent. This statement is obviously correct because for a diffraction or waves to interfere with each other, it must be coherent because coherent waves have a constant phase difference. So, due to this constant phase difference, they can form points of maxima and minima. Then, the third order intensity maxima must be produced. This is obviously wrong. So, the option C is correct. 1 and 32 are related to electric field. So, this is removed from our syllabus. So, this is not in our syllabus right now. Then in question number 33, the current in the circuit is 3.2 milliampere. What is the direction of flow and the rate of flow of electrons through the resistor? So this large side is the positive side and this small side is the negative side. So current would flow in such a way, or conventional current would flow in such a way from a positive side to a negative side. And since conventional current flow in this direction, so electron flow would occur in the opposite direction, that is from the negative side and towards the positive side. So electron flow is from the negative to the positive, that is from y to x. So y to x and y to x. So what is the rate of flow? So we know that current is equal to charge by time. We know the value of current and we need to find the time. So charge, what would be the charge? So rate of flow of electrons, and we know that the charge of a single electron is 1.6 into 10 to the power minus 19 coulomb. That is given in the question or given in the data booklet, that 1.6 into 10 to the power minus 19 coulomb, and current is 3.2 into 10 to the power negative 3 since it is milliampere. So the time is 5 into 10 to the power negative 17. So this is the time and we need to find the rate. That is, rate is equal to 1 by time period. So since it is per second, so 1 by time, we get our answer as 2 into 10 to the power 16. That is option C. Number 34. Which curve best represents the current through a filament lamp that varies with potential difference? So for a filament lamp, suppose if we draw the IV graph, then the option B would be correct, that if we extend this graph, then the graph would pass in such a way that it would be like this shape. So the option B is correct. So this is basically the graph of a filament lamp. Then this is the graph of semiconductor diode, and this is the graph for uniform resistance wire. So the graph for filament lamp would look something like this. So the option B is correct. A cylindrical metal wire X has resistance R. The same volume of the same metal is made into cylindrical wire Y of double the length, that is 2L. What is the resistance of Y? Initially for X, the resistance is basically resistivity into length by cross-sectional area, and for Y, since length is doubled and volume is same, so what is the volume of Y? So for the volume of Y, first of all, what is the volume of X? So as it is a cylindrical wire, so volume is pi r square h, that is the volume of cylinder. Then the volume of Y would be pi x square 2L, so the length is 2L, and we need to find this x, that is the radius. So since they have the same volume, so after equating this volume, we get the value of x square as r square by 2. So what is the area of Y? We know that the radius of Y, so the area of Y is pi r square, that is pi this value square, that is pi r square by 2. So this is the area of Y. So we know the area of Y. So what is the resistance of Y? Resistance is equal to resistivity into length, since it has 2L. So 2L by cross-sectional area. So the resistance of Y is this value. So if we compare, then resistance of X is R. So what is the resistance of Y? Resistance of Y is equal to 4R, since it is 4 multiplied by the resistance of X. So the answer would be C. 6. A cell of EMF E and internal resistance R is connected to a resistor of resistance R. A maximum power P is dissipated by the resistor without overheating. So for overheating or for Joule heating, we know the equation that power is equal to I square R. So this is the equation for Joule heating. Okay. What is the maximum value of E if the resistor does not overheat? So as we know that E is equal to capital IR, that is this value, plus I into small r. So this is the basically the EMF. So as we can see that these expressions are not given in terms of I. So we need to find the value of I. We know the equation that power is equal to VI, power is equal to I square R, or power is equal to V square by R. But in all these three equations, the correct value that we would get with this equation, that power is equal to I square R. So by using this equation, we can find the expression of I in terms of power and R. So after substituting the value, that is the value of I, that is root over P by R, into R plus small r. So as we can see that this is similar to this, so the option is D. So this is basically a trial and error math, that first of all you do the math with this equation, then this equation, then this equation, and as we can see that by using this equation we get the correct expression as given. But there is a hint that is easily given in the question, that without joule heating or without overheating, and for heating we know the equation power is equal to I square R, so we can just use this equation to solve and get the answer. 7. Three identical resistors, so the resistance is identical, are connected together in 4 different ways. So what would be the 4 different ways? First of all, we connect this in series, then we connect them in parallel, then we connect 2 of them in series and 1 in parallel, and 1 in series and 2 of them in parallel. So these are the 4 arrangement. Then the resistance of 2 resistors of these combinations are this value and this value, that is 4 ohm and 9 ohm. What is the resistance of individual resistor? So among these 4 combinations we have given the 2 values, that is the value for any 2 combinations. So we need to find the resistance of individual resistor. So this is basically a trial and error math. So first of all we take the resistance as 3. So if we take the single resistance as 3, then we need to find whether we get 4 ohm or 9 ohm. So as we can see that by using 3, first of all this is 3, this is 3, this is 3, so it would be 12, then this would be 3 plus 3, that is 6, and 6 and 3, that is R is equal to 1 by 6 plus 1 by 3 to the power inverse, so it would be 2 ohm. Then for this resistors, that is if we take the resistance as 3, then the overall resistance comes to be 1 ohm. And for this resistors we can see that these two are arranged in parallel, so the overall arrangement would be, first of all, for the parallel, that is 1 by 3 plus 1 by 3 inverse, then it would be 2 by 3 or 3 by 2 plus 3. So this would not be the give the value, that is it gives a value of approximately 9 by 2. So we can see that none of this arrangement gives a value of resistance 4 ohm and 9 ohm. So 3 resistor is wrong, because by using 3 none of the combination is this value, so 3 is wrong. Then by using 6 ohm resistor we can see that for the first arrangement the overall resistance is 18. Then for the second arrangement, the these two combination is 12, so 12 and this is 6, so 1 by 12 plus 1 by 6 inverse, so the overall resistance comes to be 4. Yes, this is 4, so we get one correct value. Then for this arrangement the overall resistance is 2 ohm, and for this arrangement the overall resistance is 9 ohm, so we get the second correct value. So as we can see that we get 4 ohm and 9 ohm by this combination, so 6 ohm would be the correct resistance, so the answer would be B. 8. In the circuit shown, a battery of negligible internal resistance is connected in series with a pair of fixed resistors R1 and R2. The circuit is used to test whether the EMF of a particular cell is 1.5 volt. That means the EMF of this cell is 1.5 volt. We need to use this circuit to find this. The cell is connected between terminals X and Y parallel to R2, that is these two X and Y parallel to R2, and in series with a galvanometer. So this is a galvanometer. Which statement about the test is correct? Any non-zero reading on the galvanometer means that the cell has EMF of 1.5 volt. This statement is wrong, because any zero reading means that it has a EMF of 1.5 volt, not non-zero. The battery does not need to have an EMF of 6 volt. This statement is also wrong. Then the cell may be connected either way round between X and Y. That is, if we connect the cell in like it this way, that this side is on this side and this is on this side, then this would show not this should show just an increase in reading or a different reading. So this arrangement is also wrong, because by arranging in either way we get two different EMF values, or as it is a galvanometer, so two different current values. The galvanometer does not need a scale calibrated in ammeter. This statement is correct, because whether the scale is calibrated in ammeter or whatever it is, the reading is always 0 if the EMF is 1.5 volt. So the option D is correct, because as for resistor R2 we can see that the voltage across R2 comes to be its resistance by total voltage into V total, so we get the resistance of R2 as 1.5 volt. As R2 is 1.5 volt and this resistance is 1.5 volt, So 1.5 and 1.5 cancels each other out. So the overall current is 0. Since the overall current is 0, so whether the galvanometer is calibrated in ammeter or milliammeter or whatever it is, the reading would be 0. So we don't need to calibrate it, the reading, because whether we calibrate or not, we would get a 0 reading. 39. An element has two isotopic forms. So as their isotopes are the atoms of the same element with the same number of protons and electrons but different number of neutrons. What are the nuclear arrangement of these two isotopes are correct. So they have different nuclear number, that means different number of protons and electrons. As we know that nuclear number is the sum of the proton plus sum of the neutron. So since isotopes have different number of neutrons, thus they would have different nuclear number. So yes, isotopes have different nuclear number but same number of protons. So isotopes have the same number of protons but different number of neutrons, and due to this different number of neutrons, the nuclear number is different. So option B is correct. Team, a hadron has a charge of positive E, that is positive 1 E, where E is the elementary charge. Which combination of up and down quarks form a hadron? So as it has a charge of positive 1, so by using 2 by 3, then 2 by 3, then negative 1 by 3 gives us a charge of positive 1, that is 2 by 3 is up, up and down. So the option C is correct.